So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about designing in context in Onshape. And we're going to take a bit of a different tone in this webinar in the sense that we're going to focus a lot today on how Onshape differs from in-context systems, tools of the past. Now, as I always say with these webinars, you're really encouraged to ask any questions that you'd like. There's a questions section in the GoToWebinar control panel. Feel free to ask any question that you'd like, and I'll do my best to answer the questions as we go through today's webinar. But again, the topic today, we're going to focus on designing in context, and more specifically, what we've done in Onshape to improve the in-context experience. So really, if you have experience within context in the SolidWorks or other CAD systems out there, really intended for you to just kind of showcase some of the benefits of using a tool like this. So designing in context, and again, feel free to ask any question that you'd like via the questions section in the GoToWebinar control panel. So let's dig into it. Now, the agenda today is pretty straightforward. We are going to start with a simple introduction into in-context design. So if you're not familiar with the term, just give you a simple introduction into what I mean by in-context. And then we're going to get into what's different about Onshape's approach to in-context. And the reason we're going to get into this is I think there are a lot of users out there who have come from, some of these older CAD systems that have bad experiences within context. And in fact, many of them will tell you, they don't use in context because of, these bad experiences. So just keep in mind, a lot of the benefits, a lot of the things that we've done different in context in Onshape are meant to kind of alleviate these concerns that a lot of users have had over the years for in context. And I'll explain what I mean by that in just a bit. I, of course, want to show you a few examples. So I will be walking you through a few examples of in-context design in Onshape and how it's used. And then, of course, highlight some of the capabilities of Onshape's managed in-context design tools. And we refer to it as managed in-context design because unlike a lot of other systems out there, you manage it. You control how it behaves. Now, as I always say again, feel free to ask any questions that you'd like, and I'll do my best to stop and answer the questions as we go through the webinar. So let's dig into it. Now, I want to start with a simple explanation of in context because I think that term gets thrown around a lot. And if you're not, an expert in the industry, if you're not familiar with CAD to a great degree, you may not know what that is. So I want to start with a simple explanation. What is in context? So it's a way to design parts with relationships to one another or to an assembly, more specifically. So it's a way to design parts with contextual relationships to other parts. And, if you are familiar with CAD design to a certain extent, you may be familiar with what's often referred to as a bottom-up approach. A bottom-up approach simply means you often design one part in its own space at a time, individually, and then you take all of those parts and assemble them. That was often referred to as a bottom-up approach, but that's often difficult in more complex designs. If you think of, the example I often give is an independent suspension of a car where you have, shock travel and you have, these arms that pivot and you have a spindle that rotates, and their location and position relative to each other is very, very important. All right, and that's an excellent example where I'd want to design the shock with respect to the control arms, with respect to the spin. I want to put everything together and design everything in that context. And that's the way to think of it, is you're designing these parts with relationships to other parts in the scenarios that I give you that make sense. Doesn't always make sense, but I think for more complex designs or for many designs that just have a lot of relationships between parts, it makes a lot of sense. Now, there's often other terms for this. You'll hear the term top-down design very commonly as well. I've already mentioned it just briefly. That's another way of simply saying you're designing around multiple parts in a top-down manner rather than a bottom-up manner. So that is a simple explanation into in-context design. It's definitely one of the more, what I would say, complex skills in terms of CAD design, but for more complex designs, it's absolutely a must. Now, the benefit, aside from design in general, is the fact that, of course, it makes it easy to build parts with relationships to one another. And especially if you're designing configurable designs or anything along those lines, building relationships between parts makes updating them very easy. You can control a whole bunch of parts with a single dimension or a couple of dimensions or features and make a really powerful, CAD model that updates very quickly. So it's a technique that takes some skill, but again, has big benefits. Now, with these benefits, the in-context approach, this isn't new, by the way. This has existed for some time now, but it's always had some flaws. I do want to get into those flaws in just a bit, but the question often comes up: where would I use this? Where would I, go about designing in context? And the answer I would say is, anytime you want to relate one part to another. If you're designing each part in its own independent space, that's fine. But you'll find as you get into more and more complex designs, designs with movement and all these different things, that you will want a simple way to create relationships between parts. And often in context is the answer to that. So the other example I would give is if you want to create a new part that joins two parts in your assembly. I'll give you an example of that, but you can see the screenshot on the left there of the steps tool where I have those link arms that join the steps and the frame of everything together. Well, those link arms would be a great example of something designed in context because you don't know, the distance between the points and so on. And if you're designing those link arms one at a time, you would have to take a whole bunch of measurements to figure out values and all those types of things. Whereas designing them in context, I can literally just convert entities, extrude, very simple. So it's, creating new parts is just as good a reason as editing existing parts in context. So the other example I like to give is especially with Onshapes in context design. This is something that we've done really, really well. You can capture multiple positions of an assembly. So in the example on the left, a steps tool has an open and closed position. And you may need to design around both positions. Maybe you need clearance around this position, you need some kind of mount for this position, and you need to be able to easily get between those two positions. That's an excellent example where I can create multiple contexts. Now, that's something that older CAD systems struggle to do or can't do at all, whereas at Onshape it does it really well. And I'll show you an example of what I mean by that in just a bit. So these are just a few examples, areas that I would point out where you might use in context design, and I'm going to go over examples of each of them in just a bit. But I want to jump into, kind of the pitfalls of in-context design in the past, and it's something that I think a lot of users have really shied away from for a various number of reasons. One of the things that's almost universal when you talk to engineers about in-context design in some of these older CAD systems is that it is a fragile process. It tends to be an error-prone process. It's very much a cumbersome process because of the nature of how it behaves. And what I mean by that is, simple things, just like moving a part in the assembly and then rebuilding the model will cause these designs to update in ways that you don't really predict or would want. Right. The example that you see there on the left, I'm just moving a simple plunger arm. Yeah, and you can see the clamp arm adjusts and updates. Right, and the frame is not something that I'd want to see update just from a simple movement. Right, but that's an excellent example of the unpredictable ways that it would update. And rebuilds happen all the time in many of these CAD systems. So this kind of unpredictable updating nature is just inherent in the way that in-context design was built. The other thing I would stress about in-context design is it's even more so than old CAD systems in general. It's very much file dependent. And what I mean by that is when you design in context, you create a relationship to oftentimes a file or a few files. And if those one or two or multiple files are moved or renamed or deleted, it has this domino effect because of that dependency. So what often you'll hear from engineers is we opened the assembly and it opened up, quote unquote, blank. I've heard that term before, and it just means that because everything was tied to a few parts and those parts moved or got changed or whatever it might be, it created this domino effect. And you have to go through and change references, whatever it may be, but it's very unnerving. And in fact, a lot of companies have either banned the practice of in-context design internally, or they require that the in-context references be severed, be broken before a design can be actually released. And these are common practices that you'll see in organizations banning these things. In fact, some of these CAD systems even have options that allow you to shut off the ability altogether. So it's something that a lot of users have struggled with for a very long time, and it's mainly due to the fact that it updates in unpredictable ways, and it's very, very dependent on files, which means if anything moves in terms of files or changes, it creates this domino effect. And that can be a very troublesome thing. Files in and of themselves are a difficult thing to manage, but when you create a whole bunch of dependencies to a single couple of files, then you kind of exacerbate the problem. It gets even worse. So just think of that when we think of some of the things that we've done in Onshape. One of the goals, one of the key things that we set out to do was make the process stable. So if you design in context, you don't have to worry about opening up the assembly and having everything rebuild in a weird way. Or you don't have to worry about everything just not rebuilding because something's missing, a file's missing. The stability of in-context design is its biggest asset, its biggest benefit. So again, what's different about in-context design in Onshape? Onshape captures a snapshot of the assembly the moment you create a context. And it takes that snapshot of the assembly and it brings that into the Part Studio so that you can work around that in the Part Studio. Now, the key thing I would stress about that snapshot that's taken when you design in context is it's immutable. It doesn't change. It's view only, so to speak. Right? So it will only be updated when you tell it to update. And that's an important distinction. Rather than being updated as it opens or being updated on the fly, you trigger an update. You tell it when to update. And that was a deliberate decision because of the unstable nature of these in-context systems in the past. So the snapshot that's taken is immutable. You think of it as, the moment you say create a context, it grabs that, assembly snapshot and it brings that into the Part Studio, and then you design around that snapshot. You can update that snapshot whenever you want, but the important thing is it doesn't change dynamically, right? So if someone goes in and then moves the assembly around, you don't have to worry about your snapshot updating on the fly. And that's something that a lot of users have really struggled with in these older CAD systems, is just the unpredictable nature of it. So it's not susceptible to movement, simple things. You don't have to worry about moving your assemblies in Onshape, causing this weird update in the in-context features. And you don't have to worry about renaming parts or assemblies or even moving things around or deleting things even. It's a moment in time that can't be erased, so to speak. So you never have to worry about it just opening up blank or rebuilding, failing to rebuild or any of those types of things. Now, the comparison I would make, if you're familiar with Onshape, is versions. In Onshape, you can click on the top left. There's an icon that says Create Version, and that Create Version captures that moment in time of the document. And it stores that so that you can come back and look at that moment in time at any point. And the in-context features that we have are very similar in functionality and how that works. And it's one aspect, one area where we've taken, the cloud aspects of Onshape and made the core CAD experience of in-context better because of it. So this is something that's very unique because we capture snapshots in a database format. We can easily call those up and have them be stable when you design around them. And that's the key theme that I would stress with in-context design in Onshape. The key difference I would stress is it's just more stable. You never have to worry about things opening up, randomly broken or weird, rebuilds or any of those types of things. All right, so those are the key differences, the key distinctions that I would make between, if you've used in context in the past and, Onshape's in context. So let's get into it. Now, the questions section in the GoToWebinar control panel is where you can ask any questions that you'd like. So again, feel free to ask any questions that you'd like, and I'll do my best to stop and address them as we go through today. question. How can edit in context be used to create modifications to part geometry that only exists in the context of the assembly? It is instance. There is no ability to create a feature that only applies at the assembly level. I hope that answers the question. You mentioned assembly cuts, and only existing in the context of the assembly. That you can't do that in Onshape. In Onshape, the part modeling, the feature creation, the part modification, let's call it, always takes place in the Part Studio, even if you're designing in context, which I'll show you in just a bit. But I think in short, there's no way to create a cut that only applies at the assembly level and doesn't show up at the part. Forgive me if that doesn't answer the question correctly. All right, so let's get into in context. And what I'd like to do is start with a simple example. And I want to start with a simple example of this pedal box and just give you an example of how I might use in context design in Onshape. And it's very easy to use, but I want to stress a few important things. It's important to keep in mind this isn't Onshape's only top-down design technique. We also have the ability to design multiple parts in a single part studio, what we often refer to as multi-part part modeling. So just realize there are two different, kind of quote-unquote top-down design techniques in Onshape. In context, which we're talking about here, and multi-part, which we've talked about in other webinars. The key thing I would stress here is assemblies, in context design is really about assembly. And assemblies are really about bringing parts from all different places. Now, those parts could be from this document. They could be from other documents. They could be imported models. It really doesn't matter. But what you'll notice in this example is, I really have a combination of multi-part part modeling. You can see I have a frame here and a few pedals. But I also have a combination of other things. I have these hydraulic cylinders that have come from, imported files. So I have a combination of things that I've brought together and I need to design around. Now, if this is the scenario that you're in, where you're using parts from this source and that source, and you've brought them all together into the assembly, and you need to make edits around all of that, in context is really the only tool that you'll use. When we talk about multi-part part modeling, you really don't want to do a ton of inserting and moving parts around inside of a part studio. That's where in context has its benefits. So the question often comes up, you have two different forms of top-down, which should I use? In this scenario, it's obvious. I'm bringing in all of these assemblies from all these other sources. I've already assembled them together. I need to work in context of the assembly. But if I'm designing everything from scratch and I have a few related parts that I want to put together, that's where multi-part part studio comes in. Available in iPad Pro UI. To be honest, I'm not certain. Forgive me. You may be able to view the context, but I don't know that you can create a context in. You'll have to forgive me. I'd have to try it. I'm not certain that you can. My gut says no. If you stick around, I can give it a shot. All right, so creating a context, really simple to do. So hypothetical scenarios, let's say that I'm designing this pedal box and I need design around this frame, and this frame has these cylinders in it. I need to design a position so that I can control where this pedal travels to. I want to be able to control kind of that max position where it travels to. And I need to create features around these cylinders. And I need to do that in a way that encapsulates not just this frame, but the cylinders and where they're located and all those things. So that's where I'd use edit in context. Very simple. You ask yourself, what part do I want to modify in context? In this case, we want to edit the frame, this gray piece here. I'll right click. I'll choose edit in context. Right, choose edit in context. And what will happen is it will take me to the part studio. So again, keep in mind, all part modification, any kind of geometry modification, is done in the part studio. Even in the situation of in-context assembly design, it just takes the assembly, brings that into the part studio as a ghosted version that you can design around. Now, as I mentioned before, the benefit of this, the reason that we think this is dramatically different than past systems is this is a snapshot of the assembly the moment I said edit in context. So the moment I click that button, it takes a snapshot of the assembly and it brings that into the Part Studio so that I can design around that. And that's the big thing. I don't have to worry about this pedal updating if someone else opens the assembly and starts moving things around. I don't have to worry about if someone comes in and deletes this pedal, all of a sudden all of the things that were tied to it fail to rebuild. That won't happen in Onshape. Right? This is a moment in time that will only update if you tell it to. It'll only update if you trigger an update. So again, the key theme being stability. Now, as you can see, I have a ghosted version of the assembly, right? As I mentioned before, the pedal, the frame and these pedal arms were in the Part Studio, but the hydraulic cylinders, the position of them, and so on, that's from the assembly. And you can see that as the ghosted version of it there. But what's unique about this, what's really cool about this is these are, no different than parts or, assemblies in the Part Studio. I can left click this face, for instance, and start a sketch, right? I can convert this edge just as if it were a part in this Part Studio, even though it's coming from the assembly, of course. So again, think of it as that I'm capturing that assembly at that moment in time. I bring it into the Part Studio and I design around it. Now, that also means that it's important to emphasize you'll want to get the position, assembly into the correct position before you edit in context, right? You'll want to move parts around. You'll want to hide parts. If parts have no relevance to the context or the features that you're creating, you can hide them before creating the context and they won't show up, right? So you'll want to take some thought into, where are my parts at? Are they hidden or are they shown? But again, it just grabs it, brings it into the Part Studio, and you design around it. Now, I haven't actually created a context yet, right? I haven't really established a relationship to that ghosted assembly yet. So therefore, I don't really have a context. It isn't until I create some kind of a relationship with the context that it actually establishes a relationship, right? So it actually adds it as a context in the Part Studio. So, for example, if I wanted to, start a sketch on the face of this arm, right? I can do that. And now I've created a context. You'll see here at the top, context 1 of pedal box created. It adds a little context here in the top of the feature list. So that's my visual cue that, yes, you have now created a relationship to that assembly context, right? Now, at this point, it's no different than anything else, right? So I can select edges, I can select faces of the part, and really treat them no differently than any other geometry. So that's the really unique thing here, is it allows you to essentially work with the assembly models as if they had been embedded in your Part Studio, because they are, right, as ghosted versions. And so it's very easy for me to come in, create some, simple sketch geometry here. Forgive me as I must fully define things. Okay, there we go. And so now I've constructed some simple, sketch geometry, and it's in relation to the pedal at its current position. Remember, I moved that pedal back to what I would call, let's say, the maximum position before I created the context. And so that's important because, remember, at that moment when you click that, it captures those positions, right? Anything that's hidden or shown with the position of all those things, then that's what it brings in. So I moved that pedal back to that position where I want it to stop, and now I'm designing around that position in the Part Studio, right? In the Part Studio context, right? So I can go from here and create an extrude, right? And extrude that up to the frame. Again, this is no different at this point than any other extrude feature, of course, right? The key, the relationship in this scenario is in the sketch and the edge that I converted and the face that I used for the pedal, right? So I hit the green check OK, and now I have an in-context reference to this, this feature. Right, and you can see that in the sketch itself, right? So sketch 6, you can see a little arrow here indicating in context reference. That's your visual cue. You'll see that in the assembly level as well for parts that have in-context references. So that's creating a simple context. Again, it's really all about the right click in the assembly level, and you want to be particular about what parts are showing, what are the positions of all the parts, because that's what's going to be brought into your Part Studio to work around. Now, once you're done creating an assembly context, you created the features that are related to that, I can click Go to Assembly, and it will take me to the assembly, but of course the part is updated to that new feature, right? So again, just keep that in mind. The other thing I would stress, this is something that gets asked often. It's something that I mentioned already briefly earlier. Do I have to worry about simple things like moving the design, causing it to fail to rebuild, or cause it to rebuild in weird ways in general? And the answer is no. The important thing that I would always stress about our in-context design is it only updates when you tell it to update. So I could move this around. I could delete this altogether, move something. I could do all kinds of different things. I don't have to worry about this dynamically updating kind of as I do that. Now, of course, you will want to, at some point, update a context. And you can do that by moving everything into the correct position. Right? Again, a common theme that you're getting, move everything into the correct position. And then you can right-click a part and you can choose to update that context. Right? And then you'll see, if I zoom in here, it's now accommodating that new lower position for that arm. But again, it doesn't dynamically do that. It does that whenever you right-click on it, and that's the key thing that I would stress. Don't be afraid to move things around, to rename things, to do whatever you'd like to do, because the assembly context will only update upon being triggered. Right? It will not update, on the fly. Even things like the question I get asked often, what about deleting altogether? And then the answer is no. It doesn't just break because of that. Remember, we capture a snapshot of the assembly and bring it in to work around it. That snapshot is never going to just break. So, question. Regarding the assembly code, I was thinking that the new part configuration capability could be leveraged to create assemblies with a different part state. Haven't had time to test the practicality of doing it. Interested in your thoughts. You could absolutely do that. It's not technically assembly configurations, and we know that. So it's not. Again, the part modification would still need to be done in the Part Studio, and there's still some limitations. We talk about a true assembly level configuration functionality that we don't have. But I think it's technically possible, at least off the top of my head, given your explanation, where I could create all kinds of different part variations and build assembly tabs for each combination. Can you save several positions of a single part in an Can you save several positions of a single part in an assembly? Yes. I think the answer to your question is what we call named positions. I think that's the answer to the question. Yes. So view saving to clarify earlier. And this is a very good point. You've also mentioned that as well, to help set up your context. So in essence, named positions allow you to capture the assembly position at that moment whenever you click, your named position. So if I go named positions, let's call this, the min position. I'll click plus, and that position will be remembered. So very useful for creating a context, because it makes it easy if I go back and I move this to something else and I wonder, how do I get back to that exact position? I can just choose min here. Right, and it will go back to that position. So that's a short answer. Great tip for those designing in context. Named positions just makes it very easy to capture a position in the assembly and go back and forth. Especially useful if your design has multiple important positions. One good example would be, like in this pedal box, I may have a maximum and minimum position. Right, this is full throttle. This is no throttle. Right, and I want to store those two positions, maybe even design around those two positions, and that's where named positions and capturing that way would be useful. So great tip. Thank you for that question. I did not mention that, so good one. Question: will my internet connection affect performance while modeling? Not an ideal scenario. Now, there are very rare occasions, I would say, what we'll call sub 3G connection. But I would say as long as you have, a 4G, equivalent, you should have no kind of issues. We've even done a lot of modeling on, tethered to a 3G connection on a phone. So it does not require a strong amount of bandwidth. Any standard home internet connection, business connection, even mobile connection is more than enough. And what's unique about Onshape is we can scale, we can adjust for factors like that. When you move the pedal, it moves past the stop. That's true. There's no limit on it. And it's important to keep in mind there's no collision detection where it stops upon a collision and so on. In order to do that, what you would do is restrict the range of motion in the mate. And I believe this is mate, but I'm not 100% certain. And you could go in and you could limit the amount of motion in the mate, and that would stop it from rotating to a certain point. But it's important to keep in mind, I can grab this and move it. It doesn't actually hit and stop, in a real physics-like scenario. You would need to restrict the range of motion with the mate. And that's something else I would tie in, especially if you're tying to, ranges of motion. Restricting that range of motion with a mate it just makes a lot of sense. So, good tip, good thing to point out for in-context design. All right, so that is a simple intro into in-context design. Again, it allows you to work around all these parts from all these various places and design around various positions. And one of the benefits that I like to stress about this technique is, again, it's very stable. It doesn't, unpredictably update in weird ways. It doesn't fall apart when you open it, so to speak, because of the files or things like that. But it also allows you to capture multiple positions and design around multiple positions. That's something I think that's really unique in the sense that it makes it just very, very easy. And this is a common workflow for a lot of people, the design around moving parts. It's very common, and it sounds simple enough, and it is. It's very common workflow where you have to design around design in a closed position, an open position, or I have design around this thing that rotates at all these different points, and I need to check all these various points. And I would want to simulate the different positions, right, and design around those positions, and that's what in context allows you to do. So in the last example, it was just one position where the pedal was all the way down, and I was designing around that position. But I could do the same thing across multiple positions. So let me give you another example. In this example, we're designing this step stool, and you can see I have the frame bar designed in a single, kind of bottom-up manner, and I've got, a layout sketch that controls everything, and I've got the base frame bar in a separate part studio, and then I've got these steps in separate parts. So everything's been designed, kind of in a bottom-up manner, except for a few parts. And that's often the case in these designs. It's not necessarily mutually exclusive. You're going to use a combination of different techniques in scenarios that they make the most sense. But in this scenario, I've brought all these things together into this step stool assembly, and I need to design a few features that accommodate for that min and max position of, in this case, the step stool. I can move it in and out, and it has these min and max points. So in that scenario, I would need to design the cutouts in this frame bar to accommodate the position of this second bar at different points, different motion, right? Different points in my movement, I should say, right? So how do we do that? Well, I right-click the part that I want to modify, right, as I mentioned before, and I choose to edit in context. Now, it just so happens I've already got a context created. Right, you saw that when I loaded the frame bar just a moment ago. So you can see the open context here, and I can choose to edit in context. That takes me back to the Part Studio. Again, remember, everything is done in the Part Studio, but here we have that existing context. Again, I had this from just a moment ago. So now we have the open position. I want to design around the open position, so let's do that. Here, let's start a sketch on plane 4. And as I mentioned before, these are really no different than parts in your Part Studio, right? So we will go in and hide part 1. And I'm just going to convert these. Again, just using, selecting use and converting them like so. So just converting edges of the model essentially. And grab that edge, okay. And I'm just capturing this frame bar in this position with this assembly context. And I can hit the green check OK. And now I've captured that position. All right. Now, if we go back, I'll go to assembly here and move into the position that I want to design around. All right. Let's move into that. Let's call it the collapsed position. And I would create a second context. That's important to stress. So I'm not changing the original one. I'm creating a new context. And I could do that just by right-click, edit in context. Remember, existing context will show up in this list, and you can edit those. But we're not editing an existing one. We're creating a second context, right? So I choose edit in context, and now I'm looking at that assembly context as I design. And I could go into the assembly and capture, both. This is the same exact sketch that we were in just a moment ago, but now I'm capturing the assembly in both positions, right? So if I just do a few more converts here, now I've reflected with this one sketch, right, both the minimum and maximum position of that arm as it pivots, right? All in this single sketch driven from essentially two different positions of the assembly captured by two different contexts. Now, one big tip that I have for you, if you get into this level of in-context design is I highly recommend renaming your context, especially if you have 2 or 3 or 4, renaming them to, collapsed, let's call it. Just helps you in the long run when you go to update them. Because remember, when you right-click in the assembly, all you're going to see is the context name. And if all you have is context 1, 2, and 3, it may not be as clear what context 1, 2, and 3 are. But if you name it open, closed, position 1, position 2, it makes it easier to update later because they correlate, right? So again, renaming your context makes sense. The key thing to stress here is, we can take these assembly, these assembly contexts and create features from them. So here we'll just create extrude, remove, and we'll do 0.5. Okay, right. So now I've created a cut in the arm that accommodates both the open and closed position of this folding step stool. I can easily mirror that to the other side. At this point, it behaves no differently than a normal extrude remove. It's the sketch that has the relationships to those in-context positions. Right. All right, so a few questions that I missed. Is there a simple way to get a list of all the mates that involve a specific instance? Yes. You can right-click, I think, Show Mates. Right-click, Show Mates. Yes, and it will show. I choose Department No Mates, of course. But you can right-click Show Mates, and it will show little icons for each mate associated with the part. And you would just right-click in the assembly and choose Show Mates. So give that a shot. This typical example stresses out the collision would be really useful in order to be as accurate as possible. It is true, and that's something that a number of users have pointed out. So it wouldn't surprise me to see that in the future. I would say let us know. Use the feedback tool and let us know if that's a really critical thing for you. We know other users have given us that feedback as well, so it certainly wouldn't surprise me to see it in the future, but I'm not aware of any plans as of this moment to do so. So, all right. So again, managed in-context design. It's a stable approach to in-context design, and that's something that I would stress if you have experience in Pat's CAD system. If you, we know a lot of users have bad experience with these CAD systems and the unstable nature, and they don't dynamically update as you change things. And then you can imagine with Onshape, multiple people can be working in the same assembly. We certainly don't want dynamic updating of context, and that's something that a lot of users have struggled with for many, many years. In-context design is not new, as I mentioned earlier, but no one's really taken a fresh look at how it works in a very long time. And so you'll hear a lot of horror stories of engineers opening up things blank. You'll hear a lot of horror stories of features rebuilding in really weird ways, and that's really what we hoped to solve with our approach to assembly context designing in context. All right, so that is what I had planned. I am going to stick around and answer any questions, so make sure to ask any questions that you would like in the GoToWebinar control panel. Again, that little section for questions. I will stick around and make sure to get to all of them. One final thing that I want to mention is if you're interested in learning more, definitely check out the Onshape Learning Center at learn.onshape.com. There's self-paced training, instructor-led training, technical briefings on a whole bunch of different topics. A great resource if you're interested in learning more about Onshape. So again, that's what I had planned. Thank you everyone for joining. Stick around. If you have any questions, type them in. I will make sure to get to all of them, but that's what I had planned. Thank you. Have a good day.